We're going to compare and contrast different types of quadrilaterals here. And what I really want to focus on are the lengths of the sides and whether or not the sides meet each other at right angles. So I'm going to say corners. Are they right angles? Because those are the two things that we're going to be focusing on when we actually start doing problems where we're trying to classify these quadrilaterals. So I recognize that there are other properties that we could be looking at when we compare and contrast, but I want to really focus in on the lengths and the corners. So let's look at rhombus and square. So if you look at the two pictures, so I'm going to show you a picture here and here where I just put those green stars. That's a rhombus and a square. And one thing that they have in common is that all four of their sides are congruent. So I'm going to put the marks on here to show that they're the same length. So even though they look different, if you measured each of those four side lengths, they would be the same. So I'm going to say that they have four equal sides. That is true about both shapes. Something that is different, though, is that in a square, the corners are right angles. So every corner in a square is a 90-degree angle, and every corner in a rhombus is not a right angle, because if it was, it would be a square. So I'm going to say that in a square, we have perpendicular lines, because these two lines, like if I took two sides of a square, they would be perpendicular to each other. That's how they make the right angles. So in a square, we have perpendicular lines, and in a rhombus, we do not have perpendicular lines. So I'm just going to say not perpendicular. All right, let's talk about rectangle and parallelogram. And this is actually going to be very similar to what we just talked about with a square and a rhombus. The rectangle and the parallelogram are similar to each other in that they have two pairs of congruent sides. So the pairs that are opposite from each other, like the long sides on the top and the bottom of the rectangle, those are congruent. And then also the short sides that are on the right and left side are congruent to each other, but they're not all four congruent, because then it would be a square. So that's true also of parallelogram. So the top and the bottom are opposite and equal, and then the two sides are opposite and equal. So they're similar in that they have two pairs of opposite equal sides. And then their difference is actually the same as it was for the rhombus and the square. A rectangle has four right angles, meaning that the sides are perpendicular. So for the rectangle, we have perpendicular sides. And for the parallelogram, they are not perpendicular, because if they were, it would be a rectangle. So for the parallelogram, the sides are not perpendicular. All right, let's talk about square and rectangle. When I'm looking at the two pictures, so let me put a new purple, I'm going to use a different color. We'll do a red star. So the red stars, those are both the ones I'm looking at now. What they are different, or the way that they're different, is that a square has four equal sides, and the rectangle has two pairs of opposite equal sides. So I'm going to say that the sides are different. I'm sorry, I should be talking about, I did this backwards. So the sides are different. So in a square, you have four equal, and in a rectangle, you have two pairs of opposite equal sides. And then when we're talking about the similarities, which I should have done first, I apologize for that, is that they have four right angles. All of their sides are perpendicular to each other. So I'm going to say that their sides are perpendicular. Okay, so now let's talk about the kite and the parallelogram. I'm going to use blue for this one. So here's the kite and then the parallelogram up here. So the way that they are similar is that they don't have right angles, or they don't necessarily have to have right angles. So in a parallelogram, we know that there are no right angles, because if it did, it would be a rectangle. And then in the kite over here, it's also not going to have right angles. So I'm going to write that the sides are not, or the sides don't have to be perpendicular. And the reason I'm saying it that way instead of just saying that they're not is because in a kite, it would be possible for you to have a right angle, like maybe up here. That's a possibility, but it's not a guarantee. It doesn't have to be that way. So most of the time it's not going to be right angles, so I'm just going to say they don't have to be right angles. And then the way that they're different is because of their sides. So if you look at a parallelogram, the opposite sides are equal to each other, and if you look at a kite, the adjacent sides are the ones that are next to each other are equal. So I'm going to say over here in a parallelogram, you have opposite equal sides, and in a kite, you have adjacent equal sides. All right, last but not least, we're going to talk about, let me find a new color. We'll do orange this time. We're going to talk about parallelogram versus trapezoid. So trapezoid we haven't talked at all about yet. So some things about trapezoids. The top and the bottom sides are not going to be equal to each other. If they were equal to each other, then it would be either a parallelogram or a rectangle. But they're not going to be equal to each other. So this top side and this bottom side are different lengths. And then if you look at the sides, they're slanted. So they're not going to make a right angle. And again, you could have a trapezoid where there is a right angle, but it's kind of like an outlier. It's not the norm. So it's kind of like this kite situation where you could have a right angle, but you don't have to. All right, so some ways that they are similar is that the sides don't make right angles. And I'm going to say it the same way that I did for number 4. I'm going to say that the sides don't have to be perpendicular. And then as far as the ways that they're different is the trapezoid doesn't have any equal sides, and the parallelogram does. So I'm going to say that the trapezoid has no equal sides. And again, especially if you look at this picture, it looks like these sides are the same. That would be an isosceles trapezoid. But again, that's kind of like it's one case where it works. So I'm going to say no equal sides, and I'll put like a little asterisk next to that because it's possible that you might have two that are equal. But in a parallelogram, you always have two pairs of opposite equal sides. When you're given information about a quadrilateral and you're trying to determine which one it is, there's kind of a 4-step process that you want to follow. The first thing that you want to look at are which sides are equal. So I'm just going to say look at your sides. And then I'm going to go over to this little thing on the right here. There are 2 shapes where all 4 sides are equal. And those shapes are the square and rhombus. So if you see that all 4 sides are equal, you are already narrowed down to 2 options. It's either a square or a rhombus. There are 3 quadrilaterals that have 2 pairs of equal sides. They are rectangle, parallelogram, and kite. So if you are given information and you see that you have 2 pairs that are the same, but they're not all 4 the same, then you're narrowed down to 3 options. It's either a rectangle, parallelogram, or kite. And then if something weird is going on, like you have 4 different sides, or maybe you have 1 pair that's the same, and then the other 2 are different, then there are 2 options, and it's actually the same shape. The first option is that it could just be a generic trapezoid. And I'm going to put a little note here that if it's a generic trapezoid, you should have 4 different sides. So you'd have 4 different lengths for the sides. Nothing would match. If And then the other option, if something weird is going on, is that it could be an isosceles trapezoid. And what happens in an isosceles trapezoid, I'm going to draw a quick picture over here, is that these two distances would be different, but then your sides would be the same. So you'd have one pair that are the same, like you'd have a pair of equal sides, and then you'd have two other different sides. So you'd have two equal and then two different sides. Okay, so that's the first thing, is you would look at the sides. Depending on how many are equal, you can narrow it down to these choices. The next thing that you're going to do is look at how the sides meet each other. And what I'm talking about is the slopes. Are they perpendicular to each other? Do they have right angles at the corner? Or do they not? So I'm going to say look at your slopes. And specifically what you're looking for is, are the sides perpendicular to each other at the corners? And then from there, you're going to choose the correct shape in the category that you already narrowed down, and you'll be good to go. So let's go through and just kind of write down for each shape, what you're looking for. So in a square, we talked previously about how squares have 4 right angles. So if you look at two sides that are next to each other, two sides that make a corner, the slopes are going to be perpendicular. Okay, and by the way, just in case you're not sure, this upside down T is a symbol for perpendicular. But perpendicular is kind of a long word, and so it's a lot easier just to write the symbol. So in a square, you'd have 4 equal sides, and then you'd also see that the slopes are perpendicular, which, by the way, just as a reminder, means that they would be opposite reciprocals. All right, in a rhombus, we do not have right angles at the corners. So what that means is that my slopes are not going to be perpendicular to each other. So you'd be looking for something that's neither, because I don't want parallel lines. You will have parallel lines, but they're the ones opposite from each other, and we want to look at the ones that connect to make a corner. So they will not be opposite reciprocals, and they will not be the same. All right, let's move on to where you have 2 pairs of equal sides. In a rectangle, just like in a square, you're going to have perpendicular slopes, because the corners of a rectangle make 90-degree angles, so you're going to have opposite reciprocals. Parallelogram is going to be the same as a rhombus, where your slopes are not going to be perpendicular. And then a kite is kind of weird. You don't necessarily need to look at the slopes, because looking at how the corners of a kite measure up as far as their angles go isn't going to help you identify that it's a kite. What's going to help you identify it, and I should have probably written this down when we were talking about the sides, is that when you look at the sides that you're given, the 2 that are next to each other are going to be the same, not the 2 that are opposite. So I'm going to write down here that you have adjacent sides that are equal. So I'm not going to write anything down about slope for kite, because there really isn't much to talk about there. So when you see that you have 2 pairs of equal sides, if you see that your equal sides are opposite, then you're talking about either a rectangle or a parallelogram, and you should look at slope. When you see that your 2 pairs of opposite sides are next to each other, it's automatically a kite, and the slopes are irrelevant. All right, the last thing we need to talk about is how you tell the difference between an isosceles trapezoid and a regular trapezoid with slope. And honestly, the answer is slope doesn't really matter again. And the reason is because the sides are unique. So if you have 4 different sides, that's not going to matter. The only thing pertaining to slope that might kind of make a little bit of sense, and this again doesn't have to do with perpendicular at all. In a trapezoid, and this goes for both isosceles and regular trapezoids, the sides that are opposite from each other, so I'm looking at this picture here, I'm going to highlight them in red. This side here and this side here have to be parallel to each other. So what you could do when you're looking at slopes to kind of confirm that it is a trapezoid is you could see, and this, like I said, goes for both of them, that your opposite sides, one pair of opposite sides, are parallel. So if you were given a shape that had 4 different sides and you didn't have any parallel lines, that would just be like a generic quadrilateral. But for our purposes, it's going to fall into one of these categories. So if you see that something has 4 different sides, or if it only has 2 equal sides and the other 2 are different, without really paying too much attention to slope as far as it being perpendicular or not, it's a trapezoid or an isosceles trapezoid. We're given information about the length and the slopes of a quadrilateral, and we need to classify what it is. So we have several options, 6 options actually, from the previous slides that this could be. So the first thing I like to look at are the lengths, and I notice that all the lengths are the same. So since all the lengths are equal, I really have 2 possibilities. If you look back in your notes, you'll see that the only 2 possibilities where all 4 sides are congruent, it's either a square or a rhombus. So now when I go to my slopes, the difference between a square and a rhombus is that the square has perpendicular sides and the rhombus doesn't. So what I need to do is look at these sides and decide if they are opposite reciprocals. That would mean they're perpendicular and therefore right angles. Or if they're not perpendicular, that would mean it's a rhombus. So if I look at 2 slopes here, I see that I have -3/7 and 7/3. Those are definitely opposite reciprocals. They have different signs and they're just the flips of each other's fractions. So what that means is my answer needs to be square, because not only are all 4 lengths the same, but I have each of the sides meets at a right angle, so it must be a square. So rhombus is wrong answer. So here's another quadrilateral. This one is talking, it gives you the lengths again and it gives you the slopes. One thing that might be helpful is to draw a picture. The previous one was not really, when all the sides are the same and the slopes are, opposite reciprocals, a lot of times that stuff will stick out. But if not, you can always draw a picture. And what I like to do is just draw a regular, like run-of-the-mill quadrilateral. I don't like to make it anything specific. So I just try to kind of make it look like that. And then the vertices are Q, B, H, A. And what we can do is we can go through and we can label all of these things. And sometimes that makes it a little bit easier to understand. So for QB, the length is the square root of 29. So I'm going to put square root 29. HA, which is on the bottom, so it didn't go in order this time, which is another reason it's a really good idea to draw these pictures. BH is 10, and then QA is 14. All right, now for slopes. The slope of QB is 5/2. HA, the slope is -5/2. And then for BH, it's 0, and for QA, it's 0. So the first thing I notice is that I have 2 sides that are the same length. Let's see, I have QB and HA. Those are the same length. And I know my picture doesn't look that way, but that's because I drew it so that it wasn't anything specific. And then another thing that I notice is that when you look at your slopes, these 2 lines here have the same slope. That means they're parallel. So this line and this line should actually be parallel. So I have one set of parallel lines, and then I have 2 sides that are on the ends there that are not parallel, because I can see here that they don't have slopes that are opposite reciprocals. They're opposites, but they're not reciprocals. So what that means is that I have one set of parallel sides. The others are not, and they don't meet at right angles either, because if you look, 5/2 is not an opposite reciprocal of 0. Neither is -5/2. So what this leads me to believe is that this is a trapezoid. So what I'm going to do a little bit lower, I'm going to actually redraw the picture so that it makes a little bit more sense. When you see a trapezoid, you usually see The two parallel sides are horizontal. And then I have my two congruent sides, which I highlighted in yellow. So let me label these again. So these are the square root of 29, square root of 29. This was 10 and 14. And then I know that these two are parallel. So now that you see this picture, I think it's a little more obvious that it has to be a trapezoid. And specifically, it's actually an isosceles trapezoid because these two legs here are the same distance. They're congruent. So my final answer here is isosceles trapezoid. All right, and now just a note about slopes, 0 versus undefined. The way that I drew my picture, I wasn't thinking about the 0 slopes there. 0 is a horizontal line. So that's something that you could use. Maybe it would have helped me draw my picture a little more accurately the first time. So I just want to remind you that if you have y equals a number as your equation, that is a horizontal line. Horizontal lines have a slope of 0. In contrast, if you have an x equals a number line, that's a vertical line, straight up and down. Vertical lines have undefined slopes. Sometimes you'll hear no slope instead of undefined. Those two things mean the same. So just be aware, when I see that these two slopes were 0, one thing I could have done is I could have right away put BH, and I should have labeled this here, BH and AQ. I could have put them, or sorry, QA is how they labeled it. I could have made them parallel and a slope of 0 to begin with, and maybe it would have made things a little bit easier.